Welcome to Reach 3 of the series, Unraveling the Knot, Water Movement in the Sacramento-San Joaquin Delta. I'm Bill Fleenor from the Center for Watershed Sciences at UC Davis. Previously, in Reach 2 of our series, we isolated the effects of tides on flows within the delta and then added incrementally greater river inflows to examine how different levels of river inflow affect flows within the delta. The magnitude and location of delta diversions also has a significant effect on delta flows. To better understand the effects of water diversions on flows within the delta, we will use our model to step through increasing levels of diversions to see how internal delta flows change. Water is pumped from the delta in several locations. The four biggest pumping plants are the State Water Project and Central Valley Project near Tracy, Contra Costa Water District's pumps from the South Central Delta, and the North Bay Aqueduct near Dixon. Contra Costa has two other intakes they can use when water quality dictates, but this simulation is limited to the South Central Delta, which were most frequently used in recent past. The blue arrow sides will remain the same as in Reach 2, showing water volumes moved by tides and net flows during moderate river inflows without other influences. The gold arrows will represent the effects of different levels of pumping. The top left graph remains the tides with the sum of diversions in the lower left graph. The blue line represents the instantaneous sum of pumping at all four locations. The green line is the daily average of total pumping. Steps represent 4/4 percentile values, or quartiles. The model results demonstrate how diversions originally affected the current delta before any modifications to redirect flows. Diversions under these conditions affected San Joaquin River flows more than the Sacramento River. Federal exports taken by the Central Valley Project infrastructure are drawn from South Delta channels. These federal exports are fairly constant during irrigation season. In the pumping level graph, they look like steady stair-step lines. California State Water Project exports take water from the delta into Clifton Court Forebay on high tides within short windows, so they are more pulse-like than federal exports. In the pumping level graph, they show up as large spikes. Looking more closely at the South Delta, it is clear that the Central Valley Project pumps more steadily while the State Water Project takes large gulps from the delta and stores the water in Clifton Court Forebay for subsequent pumping south. Model results also suggest that even without the barriers in the South Delta, most of the water drawn toward the pumps comes from the Central Delta reversing net flows in old and middle rivers. Without gates or flow barriers in place, the San Joaquin River downstream of Turner Cut experiences net negative flows during spring tides as water is pulled toward the pumps at higher pumping levels. We will now advance to higher diversion levels. Without pumping, as shown by the blue side of each arrow, there are net positive outflows during neap tides in Old and Middle River, dark blue side. As pumping rates increase, flow becomes increasingly negative in Old and Middle River, the gold side. So, when other parameters are held constant, as more water is pumped out of the South Delta, the more negative net flows become in Old and Middle Rivers. Some of the local South Delta flow issues have been addressed by adding barriers during the higher pumping months. The purpose of barriers in the South Delta is to keep the elevation or stage of the water high enough for farmers to efficiently pump or siphon water out of delta channels and onto their fields. It also has the benefit of improving export water quality by preventing a direct path of the lower quality San Joaquin River to the pumps. The Delta Cross Channel provides an improved route for Sacramento River water to enter the Central Delta and make it to the pumps. So now we'll look at the effects that these in-channel flow barriers have on water movements. The blue arrow sides now show the exports without barriers, while the gold sides include barriers. We'll move through several different levels of export pumping. We are using the same moderate inflows, and we are adding gates and barriers shown on the map. The barriers include the head of Old River barrier on the San Joaquin River to encourage fish to travel downstream rather than toward the pumps, and 3 agricultural barriers, Old River, Grant Line Canal, and Middle River, to control water elevations. The Delta cross-channel and gate operations are also included in this simulation. Notice that there is no change in net outflow at Martinez using internal gates and barriers, but flow distributions within the delta change significantly. Flows change in the North Delta due to the cross-channel and in the South Delta due to the barriers and cross-channel. The major overall effect is that while net flow does not change, the Sacramento River has less net outflow, while the San Joaquin River has more net outflow. Let's look at these effects more closely. We'll start by looking at the lower export level modeled. In the South Delta, one of the easier places to see the effects is at the head of Old River because there's so much less flow here with a physical Old River barrier in place. Recent operations have experimented with non-physical barriers that allow flow but still direct fish toward the main channel, such as air bubblers and sound curtains. Just downstream of Old River barrier toward the pumps, we see far less flow, while downstream on the San Joaquin River, we see more flow. Middle River downstream of the head of Old River has far less flow than it did in the absence of the barrier. Grant Line Canal barrier restricts flow toward the pumps. Likewise at Old River barrier, which restricts Old River flow to the pumps from the east, these gates produce even greater net negative southward flows through Old and Middle Rivers. As the export rate increases, the same effects are accentuated further. We see greater net southward flows through Old and Middle Rivers. At the highest export rate, the effects become more pronounced. Unnatural water movement from north to south entrains fish in the pumps and breaks up any natural gradients between the rivers and ocean that cue fish responses. The last close-up we'll view in this segment is the Delta cross-channel gates near Walnut Grove. These gates are usually closed to confine water in the Sacramento River during higher flows, or closed to discourage migrating fish from entering the central delta. When opened, the gates direct flows southward into the central delta, moving fresh water from the north to the southern delta, ensuring that water reaching the pumping plants is fresh enough for use. We'll begin by visualizing the effects of the delta cross-channel gates at the lowest export rate and work our way up to higher exports. Once the Delta cross-channel gates are open, Sacramento River water flows into the north and south forks of the McCollum and down through the middle of the Delta through Old and Middle River, which makes their flows more negative. Directing water out of the Sacramento River here decreases flow in the lower Sacramento River below the Delta cross-channel gates. Some of that water shows up as increased flow in the San Joaquin River. Notice the increased net flow in both forks of the McCollum. There is more tidal effect in the Sacramento River main channel near the cross-channel gates because of the tidal force has less river outflow to counteract it. As the South Delta exports get higher, the effects become more pronounced. Eventually, we don't get much tidal flow through the north and south forks of the McCollum. You can see that tides slow, but flow no longer reverses them. Thank you for viewing this reach of Unraveling the Knot, Water Movement in the Sacramento-San Joaquin Delta. We hope the animations help you understand effects of the management within the Delta. Please join us in Reach 4, River and Estuary, where we'll explore the transition from freshwater to marine systems in the Delta.